Hello. तो बेटा हम लोग देखेंगे कि इवन फैक्टर्स ऑफ 360 कैसे देखेंगे. दिस इज एनी ऑफ द फैक्टर कैन बी कम फ्रॉम 2. दिस इज 3. दिस इज 1 plus 2. अगेन 2 plus 1. दिस इज 3. 1 plus 1. दिस इज 2. So 3 into 3 9. 9 into 2 18. So total there are 18 factors of 18 even factors of 360. You can see here. This is 1. This is 2. This is 3. This is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So thus we are having 18 even factors and 6 odd factors. So which type of problems now come after this? Let us see. Next comes total number of sum of total number of factors, or you can say sum of all the factors. Now we will see next problem is sum of all the factors. Okay. Before going to use this concept, I would like to tell you one formula for new expression. One is called the geometric progression. Geometric progression means any sequence in which like the ratio of the terms is always same. Like this, there is a sequence 2, 6, 18, 54 up to so on. What is happening here is ratio of 6 upon 2 is 3. Also 18 upon 6 is also 3. And 54 upon 18 is also comes out to be 3. This kind of a sequence is called geometric progression sequence, and its terms are given as AR square, AR cube up to so on. And if we have to calculate the sum of any geometric progression sequence, so what we are having is I am just deriving the formula so that I can use this formula for the getting of sum of all the factors. Okay. Likewise, if I am having the terms A plus AR, the AR square up to so on. What you are observing here is first term is A, second term is AR, third term is AR square. So nth term comes out to be ARn minus 1, because in third term there is a 2, in second term there is 1. So in nth term it is AR raised to power n minus 1, and the term before it is you can say as AR n minus 2. Here the term before it is AR n minus 2. Okay. So if I multiply this by small r, what we are getting, this is A into R, AR. I am just writing this term AR to this side. So this becomes AR square up to so on. The second last term, when I multiply this term by R, it becomes AR n minus 1. So I am writing this as AR n minus 1 here. And the last term is AR raised to power n. So if I am subtracting this as, if I am subtracting these two terms, so what I am getting is S minus RS. These all terms are cancelling out. This is A minus of A R raised to power n. This is 1 minus R times of S. A 1 minus R raised to power n. So S comes out to be A 1 minus R raised to power n upon 1 minus R. Basically, I use this formula if the common ratio R is less than 1. Mod of R is less than 1. Or otherwise, I will use this formula A R raised to power n minus 1 upon R minus 1 if the common ratio R is greater than 1. Okay, ratio is second term upon first term. The constant ratio is called the common ratio. Okay, I will use sum of n terms of a GP, this formula. Why I am using, like, let us see. If I have to calculate the sum of all the factors of 24, okay, if I have to calculate sum of all the factors of 24, you can see as since the factors of 24 are 2 cube into 3 and we have written all the factors as in this format, that is we can choose any of the 4 factors for terms from here, and this is 3 raised to the 0 into 3 raised to the 1. What I am doing is, if I put a plus sign here in between them and plus sign here, let us see what we are getting. 2 raised to the 0 into 3 raised to the 0, this is 1. 2 raised to the 0 into 3 raised to the 1 plus 3. Okay. 2 raised to the 1 into 3 raised to the 0, this is 2. 2 raised to the 1 into 3 raised to the 1, this is 6. 2 square into 3 raised to the 1, it comes out to be 4. 2 square into 3, it comes out to be 12. 2 cube into 3 raised to the 0, this is 8. 2 cube into 3 raised to the 1, this is 24. So we are getting the sum of all the factors here. Okay. So by getting all the factors, we can use the geometric progression sum here, because as we have derived that the sum of n terms of a GP is a times of r raised to power n minus 1 upon r minus 1, where r is a common ratio and a is a first term. The first term in all the cases is 1, 2 raised to power 0, that is 1. The common ratio is 2, because the common ratio r is greater than 1 here. So we can use first term is 1. Total number of terms, n stand for number of terms, total number of terms. So total number of terms here are 4. That is the prime factorization 24 was 2 cube into 3 raised to power 1. So the sum of the factors comes out to be 3 plus 1, that is 2 raised to power 4 minus 1 upon me 2 minus 1. First term is 1, 2 raised to power 0. Okay. Another case, first term is again 1. This is common ratio is 3. 3 raised to power 1 plus 1 minus 1 upon 3 minus 1. Okay. That is the sum of all the factors are given to be equal to this 2 raised to power 4 minus 1. 16 minus 1, 15. Okay. This is 3 square 9. 9 minus 1, 8. 8 upon 2. That is 4. Sum of all the factors comes out to be 60. You can check here. That is 1 plus 3, 4. 4 plus 2, 6. 6 plus 6, 12. 12 plus 4, 16. 16 plus 12, 28. 28 plus 8, 36. 36 plus 4 again comes out to be equal to 60. Okay. So this is the simple formula for getting sum of all the factors. In this case as well, if we want to check the sum of all the factors for, you can say as 360. Okay. We had already, I am erasing this one. In case of 360, the prime factorization of 360 is 2 cube into 3 square into 5. So we can choose any of the factors as 2 raised to the 0, 2 raised to the 1, 2 square and 2 cube into 3 raised to the 0, 3 raised to the 1, 3 square into 5 raised to the 0, 5 raised to the 1. All the terms are in geometric progression. We need to calculate their sum. So by using the formula, this one, a r raised to power n minus 1 upon r minus 1, we can use first term is 1, this 2 raised to power 3 plus 1 minus 1 upon 2 minus 1, that is total terms are 4. Okay. 3 raised to power 2 plus 1 minus 1 upon 3 minus 1, that is 5 raised to power 1 plus 1 minus 1 upon 5 minus 1. So we can get sum of all the factors of 360 here. So we can use the formula in this expression. N is any composite number. Its factors can be e raised to power x, where e is a even prime. That is p1 raised to power a, p2 raised to power b, p3 raised to power c, up to so on, where p1, p2, p3 are the odd primes. If we have to calculate their sum, we can use the sum of geometric progression here. That is first term is 1, common ratio is e, so it becomes e raised to power x plus 1 minus 1 upon e minus 1. Here it becomes p1 raised to power a plus 1 minus 1 upon p1 minus 1, p2 raised to power b plus 1 minus 1 upon p2 minus 1, and up to so on. We are getting the sum of all the factors of any composite number. So I am writing the formula here. Sum of all factors of n is e raised to power x plus 1 minus 1 upon e minus 1, p1 raised to power a plus 1 minus 1 upon p1 minus 1, p2 raised to power b plus 1 minus 1 upon p2 minus 1, and p3 raised to power c plus 1 minus 1 upon p3 minus 1 up to so on. Hope it is clear to all of you. That is, till now we have studied, if we are having any composite number, we can calculate their total number of factors, we can get the odd number of factors, we can get the even number of factors, and we can get sum of all the factors. Okay. Now we will derive sum of odd factors. Sum of odd factors. We can see as in case of 24, the prime factorization is 2 cube into 3 raised to power 1, and the factors can be obtained in this way. If I have to calculate the sum of odd factors, it means the factors can be, there should be no 2. So this is only 2 raised to power 0. Another term will be 3 raised to power 0 plus 3 raised to power 1. That is 1 into 1, this is 1, and plus 1 into 3. So total number sum of odd factors is 4. You can see here 1 plus 3, that is 4. So if I have to calculate the sum of odd factors in this way, n was e raised to power x, p1 raised to power a, p2 raised to power b, p3 raised to power c up to so on. So odd factors can become from this way, p1 raised to power 0, because p1, p2, p3 up to so on are all odd primes. That is p1 raised to power 1, p1 raised to power 2 up to so on, p1 raised to power a into p2 raised to power 0, p2 raised to power 1, p2 raised to power b up to so on, p2 raised to power 2 up to so on, p2 raised to power b, like in this way. Since all the terms are in geometric progression, this is 1, it comes out to be p1 raised to power a plus 1 minus 1 upon p1 minus 1. I am calculating for sum of odd factors, okay. That is into p2 raised to power b plus 1 minus 1 upon p2 minus 1, and proceeding like this, we can get sum of odd factors. So we can write here as sum of odd factors of any composite number n is given by the formula p1 raised to power a plus 1 minus 1 upon p1 minus 1, p2 raised to power b plus 1 minus 1 upon p2 minus 1, p3 raised to power c plus 1 minus 1 upon p3 minus 1 up to so on. Okay. Now we will calculate sum of even factors. That is, you have to calculate sum of even factors. What should we do? Even factors can be obtained as, since n was e raised to power x, p1 raised to power a, p2 raised to power b, p3 raised to power c, and we already know that total number of factors can be come from this way, okay. E raised to power x, p1 raised to power 0 plus p1 raised to power 1, p1 raised to power 2 up to so on, p1 raised to power a, p2 raised to power 0 plus p2 raised to power 1 up to so on, p2 raised to power b up to so on. So for even factor, at least one of the factors should be 2, and some of all the even factors come from this way, at least one. E is a even prime. So here the first term is e. So sum of all the even factors is e, first term is a, common ratio is e, total terms are x plus 1, okay, 1, 2, 3, total number n, okay, e raised to power x minus 1 upon e minus 1, okay, a r raised to power n minus 1 upon r minus 1. First term is 1, this is p1 raised to power a plus 1 minus 1 upon p1 minus 1, that is P2 raised to the power B plus 1 minus 1 upon P2 minus 1 and up to so on. It comes out to be sum of even factors of any composite number n. So we can write here as sum of all the even factors as E, or you can multiply this E here as well. You can multiply E here as well. So it becomes E raised to the power x plus 1 minus of E, or you can write this as well, okay, as you wish. This is E raised to the power x minus 1 upon E minus 1, P1 raised to the power A plus 1 minus 1 upon P1 minus 1, P2 raised to the power B plus 1 minus 1 upon P2 minus 1 up to so on. We get sum of all the even factors.